When we think about the design of buildings, we often picture the intricate details of architecture, the strength of materials, and the aesthetic appeal that makes a structure stand out. But there's another crucial element that deserves our attention. Wind load. Yes, that invisible force that sweeps across our landscapes, shaping how we approach building design, especially in a diverse country like India. Today, let's dive into the importance of wind load in building design and the codes that guide us through this critical aspect of engineering. Imagine standing on a rooftop, feeling the wind whip around you. It's refreshing, invigorating, but also powerful. Wind can exert significant forces on buildings, especially in a country with varying climatic conditions, from the coastal breezes of Mumbai to the gusty plains of North India. This is where understanding wind load becomes essential. Wind load refers to the forces that wind exerts on a structure. It's not just about how strong the wind is on a given day. It's about the building's location, its height, and its shape. For instance, taller buildings experience more wind load compared to shorter ones. The shape of a building can either channel the wind smoothly or create turbulence, which can lead to increased pressure on certain surfaces. This is why engineers must consider wind load during the design phase to ensure that the structure can withstand these forces over its lifetime. In India, we have a unique challenge. Our country is vast and varied, with different regions experiencing different wind patterns. The Indian Standard Codes of Practice, particularly IS 875 Part 3, provide guidelines for calculating wind loads on buildings. This code takes into account various factors, including the basic wind speed for different regions, the height of the building, and the terrain around it. For instance, a building in a flat, open area will experience different wind forces compared to one nestled in a dense urban environment. But why is this so important? Well, let's consider the consequences of neglecting wind load in design. Insufficient consideration can lead to structural failures, which can be catastrophic. Think about it. A tall skyscraper swaying in the wind might look elegant, but if it's not designed correctly, it could face serious issues. In fact, we've seen examples around the world where buildings have failed due to inadequate wind load calculations, resulting in loss of life and property. As engineers, we have a responsibility to create safe and resilient structures. This is where the beauty of codes and standards comes into play. They not only provide a framework for design, but also ensure that we adhere to best practices. By following IS 875 Part 3, we can confidently design buildings that can withstand the forces of nature, ensuring the safety of occupants and the longevity of the structure. Moreover, as we embrace modern technologies in building design, tools like STAAD Pro and Etabs have revolutionized how we approach these calculations. They allow us to simulate wind loads and understand how different designs will perform under various conditions. This empowers civil engineers to innovate while keeping safety at the forefront of their designs. In conclusion, the importance of wind load in building design cannot be overstated. It's a fundamental aspect that influences how we construct our buildings, ensuring they stand tall against the forces of nature. By adhering to the Indian Standard Codes of Practice, we can create structures that are not only beautiful, but also safe and resilient. So, whether you're an architect, a structural consultant, or a civil engineer, remember that every decision you make in the design process is vital. Together, let's build a future where our structures can weather any storm, standing strong and proud against the winds of change.